Good evening. Now I'm going to explain you how to uh, create and run a program in Mplab. So for that, what you have to do is you just have to look in for the folder or the place where you find your Mplab. That is the shortcut key. So on my desktop, I can able to see here my Mplab shortcut key. I'm double clicking on that key. On that icon, and I can able to see the Mplab main screen is open here. Now I'm clicking on the file menu so as to create a new project. So select a standalone project and then press next. And you have to select the particular device. Our device is PIC16F877. So I'm typing and then I'm selecting the simulator as the hardware tool, and under the compiler I'm selecting MPASM. I'm pressing next and then I have to give a name for my project. I'm here giving the name as test CAA. Any name you can give. Once the name is done, the process of creating the project is over. Now the project is created. Under the project, you can see so many files, out of which my requirement is the source file. I'm right clicking on that, selecting the source file, right clicking on that source file and go to new and then select ASM file. Once this process is done, you have to give a name for ASM file, before which you have to give the extension for the ASM file. So I'm giving the name for my file as expp1 and the extension is set to be ASM. Once this is done, the file creation process is also over. Once you click finish, you can able to see under the project test, under the source file, your ASM file is created. Now I'm going to write the program. Since we have already written the program, I'm just copying the first program to add two 8-bit numbers and I'm saving it, means I'm copying it in my editor window. And then once the program is typed, you have to go back and you have to save your file. So once this process is done, I'm saving the file. All files will be saved. And then I have to go to run menu. Clean and the build project should be done. So I'm doing this process so as to check for any errors. So if there is no error, you will get errors equal to 0. And then it will also tell you, that is, if there is any error, you will get some error and that particular line and how many errors, everything will be described in the output file window. If you are getting error, you have to debug the error, do the same process of cleaning and building. And suppose you are doing any interfacing experiment, then you can able to see even the X file for this particular ASM file is also generated and the location of that particular file is also seen there. CC drive dot HEX is the location where the X file for this particular ASM file is stored. So this can be used while you're doing any interfacing experiments. Okay. Now I'll tell you the next process, that is after you build your project, you should go for the debugging process. So go to debug, then select discrete debug operation, and then you select build for debugging. And then while you are doing this also, you can able to see the build process is successful and the debug file is also created. Now, as per this program, we are going to add two 8-bit numbers. The location for the data is 20 and 21H, and I'm giving two data there, 45 and 1. Now, I'm going to launch my debugger. So in this place, I'm giving the data and going again to debugger, and then I'm selecting launch debugger. Once this process is done, you can able to see that there is a green color arrowhead on the program line, and the single step execution process is also executed. I'm clicking on that single step button. When I click one time, the cursor goes to the next, the arrow, green arrow goes to the next line. When it comes to the temporary termination, that is here, go to here line, you find the output is obtained in the two consecutive locations. Suppose I want to check with some other data, I can do the refresh, and the cursor goes to the first line, and I'm giving the new data here. As you see, I'm giving some data FF. The second data is also FF. Now I'm doing the same process again. And when I do, you see that the answer is 1 FE, which contains a carry. And the cursor is also moved to the last line of the program. And again, I'm doing this by refreshing the button. I'm giving some other data. So when you want to give repeatedly check with different data, you should give the refresh button, and then you should go ahead with the single step execution. See, I'm giving another data here. I'm giving 1 and 2, and again I'm doing the single step execution. The arrow is there on the first line, and as I proceed further, with every single single click on the single step execution button, the arrow goes to the next line, and you see when it comes down, we get initially the value that is 1 plus 2, and as per the result, it should not give any carry. And as you scroll down, you see that the next location is becoming 0, which means there is no carry generated. So this is how we should do for all other programs. I'm stopping with this. Thank you all.